So in this session, we are going to start our discussion about demultiplexers. Okay. So we will discuss about demultiplexers followed by decoders and encoders. So let us start our discussion with demultiplexers. So let us see what do you mean by demultiplexer. So this demultiplexer is opposite to your multiplexer, and this demultiplexer is also a combinational circuit that is going to have only single input and it is going to have 2 power n outputs. So it is going to have single input and it is going to have 2 power n outputs. Whereas in the case of your multiplexer, you are having 2 power n inputs and single output. Whereas in the case of demultiplexer, you are going to have single input and 2 power n outputs. And here we are going to have n select lines. We are going to have n select lines. So basically, according to this select line, we are going to decide which output will be connected to the input. Okay. So depending upon your select lines, your output will be connected to your input. Okay. So coming to block diagram of your demultiplexer, it will look like this. So this is your demultiplexer block diagram with 1 is to 2 power n outputs. So only one input and 2 power n outputs. So you are going to have 2 power n outputs and only one input. And how many select lines we will have? So total we will have n select lines in the case of your demultiplexer. So in the case of multiplexer and in the case of demultiplexer also, you are going to have n number of select lines only, but the difference will be lied in the input and output. Okay. Yes. So coming to type of demultiplexers, again the type of demultiplexers will be decided according to the value of n. So let's say if n is equal to 2, then we are going to form 1 is to 2 demultiplexer. We are going to form 1 is to 2 demux, where 1 is your input and 2 is your number of outputs. 2 is your number of outputs, and for this we are going to have one select line. For this we are going to have one select line. And let's say suppose if n is equal to 3, then we are going to have 1 is to 2 power 3, which is 8 demux we are going to form, where here it will represent your input and this is going to represent your output and this is going to represent your and this particular 1 is to 8 demux will have basically 3 number of select lines. So this is how we are going to decide what is the type of demux we are going to have. Okay. First, let us see your 1 is to 2 demux and let us talk about 1 is to 4 demux and so on. So this is your 1 is to 2 demux. Let us see the block diagram first. So this is your 1 is to 2 demux, where it is going to have one number of input and two number of outputs like this. Okay. So this is your input, and let's say let us represent your output as y0 and y1. Okay. And you will have one select line as s, and let's say input is I. So coming to this truth table of this 1 is to 2 demux. So the truth table will look like this. This is your select line, output y0 and y1. Now if your select line is equal to 0, then your y0 will be equal to y0 will be equal to 1 and y1 will be equal to 0. And if your select line is equal to 1, this is 0 and this is 1. Okay. So this is how we are going to decide the output. So if your select line is equal to 0, this output will be connected to your input, or if the select line is equal to 1, this output will be connected to the input. So depending upon the value of your select line, the output will be decided. So if your s is equal to 0, then y0 will be equal to 1 and other output will be equal to 0. Okay. So the equations for y0 and y1, we can write it as y0 is equal to s bar into I and y1 is equal to s into I. So you can substitute the values of s and you can check it out. So whenever your s is equal to 0, y0 will be equal to I, and whenever s is equal to 1, y1 will be equal to I. So this is the equations of your demux. So is it clear? Okay, first we will discuss one more type of multiplexer, which is 1 is to 4. So coming to 1 is to 4 demux, again the same story. So we will have one input and 4 number of outputs, 1 2 3 4, y0, y1, y2 and y3. Okay, and we will have two number of select lines like this, s1 and s0. Okay, so depending upon the values of s1 and s0, your y0 will be connected to the input. Okay, so depending upon the values of s1 and s0, it is decided which output will be connected with the input. Okay, so s1, s0, y0, y1, y2 and y3. So this is your truth table for this, and depending upon the values of s1 and s0, 0 0 0 1 1 0 and 1 1. So here it will be 1 your out, here you will get your input and remaining will be equal to 0. And if 0 1, here you are going to get your input and remaining are 0. And if it is 0 0, input 0. And for 1 1, you're going to get your input at y3. Okay, so this is how you are going to decide your which output is going to get your input. Okay, and coming to the equations of your outputs, these are again same. Y0 will be equal to s1 bar into s0 bar into input, and y1 will be equal to s1 bar s0 into input, and this is s1 s0 bar into input, and this is s1 s0 into the input. So this is how we are going to frame the equations of your 1 cross 4 demultiplexer. Now, let's say, suppose, let us take an example. Let's say if we want to design a half adder using a demux. Okay. So, okay, using a 1:4 demux. Now, how to design this? Can anyone tell me? How to design a half adder using 1:4 demux? How to design a half adder using 1:4 demux? So, how many demux do you think we will have in this particular case? How many 1:4 demux do you think we will have in this particular case? So, your half adder, it is going to have your sum and carry. Okay, so half adder, it is going to have sum as well as carry. So sum, what is the minterms for your sum? Can anyone tell me? And what is the minterms for your carry? Minterms for sum and minterms for your carry. Anyone remember this? So the minterms for your sum are 1 comma 2 and the minterms for your carry are 3. Okay, so this we need to using this minterms we are going to design our demultiplexer. Okay, so how to design this? So we'll take a 1:4 demux like this, 1:4 demux with one input. Okay, and here you are going to apply your A and B now. So this is your y0, y1, y2 and y3. So y1 is nothing but a bar dot b bar, and if you apply your input as 1, then it will become 1. So this is minterm m0. Okay, and this is nothing but a bar b into 1, which is minterm m1, and this is a b bar into 1, which is minterm m2, and this is ab into 1, which is minterm m3. Okay, so what outputs we should consider? So we should consider y1 and y2, and we should give it to a OR gate and for getting a sum, and we will consider y3 for getting a carry. Okay, so I'm going to take this demultiplexer. This is a b. Okay, and here we are going to get our input. So this we are going to make it to ground. This is y0, and y1 and y2 we are going to give it to a OR gate. So y1 and y2 we are going to give it to an OR gate, and here we are going to get our sum, which is nothing but a XOR with b, and here at y3 we are going to get carry. Okay, which is nothing but a dot b. So this is how we are going to design a half adder using 1:2 demux. And not only this half adder, you can also design half subtractor, full adder, full subtractor. Okay, or any function which is having minterms. Okay, so any two variable function you can easily implement using a 1:2 demux. Any two variable function which is having from minterms m0 to m3, we can implement it using this demux. And any three variable function, if you want to implement, you can use it. You can use a 1:2. Sorry, you can use a 1:8 demux. You can easily implement using that 1:8 demux. Okay. Yes. So shall we move forward? Is it clear? Any doubts or any queries in this? So let's say if we want to develop a 1:8 demux using 1:4 and 1:2. So let us see. So we need to implement a 1:8 demux using 1:4 and 1:2. So implementing 1:8 demux using 1 is to 2, and 1 is to 4. So let us see how to implement this 1 is to 8 demux using 1 is to 4 demux. And for 1 is to 8 demux, we are going to have only one input, and we have only one input and 8 outputs. Okay, so this we need to implement this. Okay, so how to implement this? So we are going to take a 1 is to 2 demux at the first stage. So this is 1 is to 2 demux at the first stage, which is having only one input and two outputs, like this. Now, so in the second stage, we are going to have two demultiplexers. This is 1 is to 4 demux, and this is one more 1 is to 4 demux. Okay, and this we are going to get 1 2 3 4, 1 2 3 4. These are my outputs, and here I am going to give my input, and this is going to have a select line S2, and these are going to have the select lines S1 and S0. These are going to have the select lines as S1 and S0. So if S1 and S0 is equal to 0 0, then this output will be connected to this demultiplexer. Okay, so here you are going to get Y0, Y1, Y2, Y3, Y4, Y5, Y6, and Y7. So if S1 and S0 will be equal to 0 0, then Y0 will be connected, and this multiplexer will be activated. And if your S2 is equal to S2 is equal to 0, then this output will be active. That is, this multiplexer, the input will be carried out to the first demultiplexer. If S2 is equal to 1, then the input will be traveling to this second demultiplexer. Depending upon the value of S2, whether the input should be traveled to the first demultiplexer or the input should be traveled to the second demultiplexer will be decided. Okay. Now, if the first demultiplexer is activated, then which output will be active is decided by this S1 and S0. If S1 and S0 are 0 0, then your Y0 will be activated, and Y0 value here you are going to get your input. And if S1 and S0 are 0 1, Y1 will be given, and so on. Okay, so this is how we are going to develop a 1 is to 8 demux using 1 is to 2 and 1 is to 4 demultiplexers. And similarly, if I want to develop a 1 is to 16 demux using 1 is to 8 and 1 is to 2, the same process I am going to follow. How to design this? In the first stage, I am going to have 1 is to 2 demux, which is going to have only one input and a select line. This is S3. Okay, and because your 1 is to 8 demultiplexer will how many select lines? Sorry, 1 is to 16 demultiplexer will have 4 select lines. Okay, the fourth select line is given to here, and according to the select line, you are going to select which demultiplexer should be selected. So here you are going to have 1 is to 8 demultiplexer, and here you are going to have another 1 is to 8 demultiplexer. So you are going to have 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8. Okay, so why not to Y7 and Y8 to Y15 will be given. Okay, and here you're going to have 1 2 3 select lines, S2, S1, and S0. Okay, so depending upon the value of S3, whether I should select this multiplexer or the second multiplexer will be decided, and depending upon the values of S2, S1, and S0, my which output will be active, so that will be selected. So this is how I am going to design a 1 is to 16 demultiplexer using 1 is to 8 and 1 is to 2 demultiplexers. Now if I want to design a 1 is to 8 demux using only 1 is to 2 demux, okay, I need to develop 1 is to 8 demux using only 1 is to 2 demux. Okay, this is my question. So how to develop this? Again, first it is opposite to your multiplexer. So where you will have in the case of your multiplexer, if you remember in the previous session also, in the first stage we will have the number of multiplexers, and going to the right side the number of multiplexers will be decreasing. And in the case of demultiplexers, in the first stage you are going to have only one multiplexer, 1 is to 2 demux, okay, which is going to have one input, and this is going to have two number of outputs. Okay, now these outputs are going to select which multiplexer should be selected. Here in the second stage you are going to have two demultiplexers, 1 is to 2 and 1 is to 2. Okay, now this 2 will be selecting the further multiplexers. So here we are going to have 1, 2, 3 and 4. So 1, 2, 3, 4, 5, 6, 7, 8. So here you are going to have y0, y1, y2, y3, y4, y5, y6 and y7. So this is how you are going to design a 1 is to 8 demultiplexer using 1 is to 2 demultiplexer. And here you are going to have S0, and here you are going to have S1, and you are going to have S2s. So these two are being connected with controlled with this S2, and these two are also having the S2. Okay, so depending upon the value of S0, whether this multiplexer should be selected or this, it is decided. Okay, so after that, depending upon the value of S1, whether you should select this or this will be selected, and depending upon this S2, whether Y0 should be selected or Y1 will be selected, Y1 should be selected, is decided using this select lines. Okay, yes, so this is how we are going to develop a lower order multiplexers using higher order multiplexers. Okay, so is there any doubts or any queries up to here? So this is about your demultiplexers, and so this is about your demultiplexers, and related problems to demultiplexers we will discuss in tomorrow's session after discussing about encoder and decoder. Let's try to discuss about encoders now. So what do you mean by encoder? So encoder, it is also a combinational circuit that is going to convert a set of binary inputs into a unique binary code. Okay, so the binary code represents the position of input and is used to identify the specific input that is active. So basically this encoder is going to have how many inputs? So this encoder is going to have 2 power n inputs, and it is going to have n number of outputs. This encoder, it is going to have 2 power n inputs, and this is going to have n number of outputs, and this encoder is not going to have any select line or something. Okay, so this is your encoder diagram. This is your encoder where it is going to have 2 power n inputs like this, and it is going to have n number of outputs. Now, so depending upon again the value of n, so the type of encoders will be decided. So if n is equal to 2, then the type of encoder is 4 is to 2 encoder, 4 to 2 encoder, that is 4 number of lines and 2 number of inputs. And if n is equal to 3, then we are going to have 8 to 3 encoder. And if n is equal to 4, we are going to have 16 is to, n is equal to 4 means 2 power 4, 16 is to 4 encoder. So depending upon the value of n, the type of encoder will be designed. So let us try to understand your 4 to 2 encoder first. So let us try to design your 4 to 2 encoder. So the block diagram of your 4 to 2 encoder will look like this, with 4 number of inputs, 1, 2, 3 and 4, and these are your outputs, 2 outputs. Okay, so this is going to have your inputs I0, I1, I2 and I3. This is your 4 is to 2 encoder, and it is going to have your outputs Y0 and Y1. Now in this encoder, this input lines, so basically these are your input lines. So at a time only one input line can be active. Okay, so at a time only one input line can be active. This is the requirement of this encoder. So at a time only one input line can be active. Okay, now this input line is nothing but it is equivalent to decimal 0, and this is equivalent to decimal 1, this is equivalent to decimal 2, this is equivalent to decimal 3. Let's say suppose if you are very new to this binary number systems, you don't know anything, just you know the numbers. Okay, you just know the decimal numbers, you know 0, 1, 2, 3, but you don't know the binary equivalence of that particular number. Okay, so what you're going to do, if you are just going to press this particular button which is I0, you know you are pressing the button which is associated with 0. Okay, so what you are going to get your output as Y0 will be equal to 0 and Y1 will be equal to 0. Okay, and if you are pressing I2, okay, you know the it is a decimal number 2, and what is the output you are going to do get? So what is the binary equivalent of this particular 2? 2 is nothing but 1 0. And if you are pressing 3, okay, then what is the equivalent of the 3? 3 is nothing but 1 1. So depending upon the input line you are selecting, okay, you are going to get your binary equivalent at the output. Is this clear? Exactly. So by this logic, we are going to write down our truth table with inputs at the left hand side and outputs at the right hand side. Okay. So what are the inputs we have? I naught, I1, I2, and I3. And what are the outputs we have? Y1 and Y0 is the outputs. So what you're doing, if you are pressing 0, if you are keeping all this as 0, and if you are pressing I3, okay, then what is the equivalent of 3? 3 is nothing but 1 1. And if you are pressing 0 0 1 0, what is your equivalent? You are getting 1 0. Okay, 0 1 0 0, you are getting 0 1. And if you are pressing 1 0 0 0, you are simply getting 0 0. Okay, depending upon the line which you are selecting, you are going to get that particular output. So you are basically encoding the things. Okay. Now from this truth table, we can simply write the value of y naught. Y naught is nothing but combination I3 plus I1. Okay. So y naught is nothing but when you are going to get y naught, if you are going to get your output y naught, if you are going to press or if you are going to apply I3 or if you are going to apply I1, okay, then you are going to get your y0. And when you are going to get y1, you are going to get y1 when you are going to apply I3 or when you are going to apply I2, I3 plus I2. So this is how you are going to get your outputs. And if you want to see that logic diagram for this, one OR gate and one more OR gate, and this is I3, I2, I1 and I0, and this is Y1 and Y0. Okay, and this I3 will be connected. Sorry, this is I3 and I2. So the I3 and this is I1. Okay, and we will have I2 here. So this I3 is connected to this. Okay, so I3 plus I1 is Y1, is Y0, I3 plus I1, and Y1 is nothing but I3 plus I2. Coming to n is equal to 3. N is equal to 3 means it will become 8 to 3 encoder. That means it is going, this is also known as octal to binary encoder. It is also known as octal to binary encoder. Because in octal representation, you are going to have 8 number of digits. Okay. And if you want to convert any octal number into binary, what is the equivalent? You are going to convert each and every digit of octal number into 3-bit binary equivalent. Okay. So that is what we are doing with this 8:3 encoder. So this is your 8:3 encoder, which will have 8 inputs, 1 2 3 4 5 6 7 8. Okay, I0 to I1, I2, I3, I4 to I7. Okay, and you will have 3 number of outputs, that is Y2, Y1 and Y0. Okay, you can remember this encoders as a small child toy. Okay, so he don't know what is the equivalent of, what is the binary equivalent of this octal number. So what he will do, he will just press I4, okay, or I4 button, or he is going to activate, he's going to close the switch which is related to I4. So what is the output we are going to get? The output we are going to get is 100. Okay, and if we are going to press I7, then we are going to get 111. Okay, so this is how you can remember this. Okay, and depending on this, we can draw the truth table like this: I7, I6, I5, I4, I3, I2, and I1. Okay, and Y3, Y2, Y1, Y3, Y2, Y1, or Y2, Y1, Y0. So if I7 is high and remaining all are zeros, then you are going to get 1 1 1. Okay. Same if I6 is high and remaining all are 0, then you are going to get the corresponding output, that is nothing but 1 1 0. Okay. And if I5 is 1 and remaining all are zeros, then you are going to get 101. And if I4 is high and remaining all are zeros, then you are going to get the respective output as 1000. So like that, depending upon the input and depending upon the input which you have applied, so you are going to get that particular corresponding output. And please remember that here in the case of encoder, only one input line can be active. And if more than one input line is active, then you are going to get your output as unknown. Okay, so the encoder will not work. So you should only apply any one line as your input. And coming to the last encoder, we have decimal to BCD encoder. Okay, so basically we have decimal to BCD encoder. Now, what do you mean by this decimal to BCD encoder? What do you think? How many digits we will have at the input, and how many outputs we will have at the output? 10 digits at the input, and how many lines at the output? Okay, so decimal we will have 10 inputs, and at output we will have 4 outputs. Now, is there any encoder like 10 is to 4 encoder? Do we have any encoder as 10 is to 4 encoder? No. So what we are doing? So what can we do to design this 10 is to 4 encoder? So we are going to consider what encoder we can consider. We can consider 16 is to 4 encoder, and the input lines and the 4 input and the 6 input lines will be disabled. Okay, so you can take 16 is to 4 encoder with 16 inputs, and all the 6 inputs will be grounded, and you are going to get your 16 is to 4 encoder, sorry, 10 is to 4 encoder. Okay, is it clear? So by considering the 16 is to 4 encoder and by disabling all the 6 inputs, we will get 10 is to 3 encoder like this. So on 10. So I0 to I9 are your inputs, and your outputs are Y3, Y2, Y1 and Y0. Okay. So coming to the truth table of this. Okay. So depending upon, and we will have Y3, Y2, Y1, Y0. Okay, 4 outputs. So depending upon the value of line input you are going to apply, so the output will be decided. So if you are applying I9, then your output will be equal to 1001. So basically you are converting decimal to BCD encoding. Okay, that we have already seen. This conversions already we have seen, but we are learning here with the help of encoders. That's it. Okay, if you are applying I3, then it is nothing but 0011. So depending upon the value you are applying at your input, your output is being decided. Okay. So this is nothing but your decimal to BCD encoder. Okay. Now, one disadvantage of this encoders is you can only apply your only single input. You can apply only single input. More than one inputs you are going to apply, you are not going to get your output. Okay. So for resolving that particular issue, which we are facing in this particular encoder, we are going to discuss another type of encoder, which is known as priority encoder. Okay, so we are going to discuss about one more type of encoder, which is known as priority encoder, that we will start our discussion in our next session. Okay, so we will discuss about what do you mean by priority encoders and how these are different from your normal encoders. Okay, what is the use of this priority encoders, and after that we are going to discuss about decoders. Okay, after encoders and decoders, I think we have tri-state buffers also. The tri-state buffers, how to use this tri-state buffers, everything we are going to discuss, and we will practice some problems related to this combination circuits. Okay, so that is the agenda which I'm planning, and